This video will introduce how to calculate the future value of a single payment or a lump sum. Our future value is the amount of money an investment will grow to over some period of time at some given interest rate. So for example, if we were to save or invest a certain amount in the bank today, our future value would be the value that it would be after earning all of our interest. Another way to think about future value is that it's some cash flow in the future that we might need to calculate the present value for today. So future cash flow is either going to be the amount an investment grows to, or it's a value at some point in the future that we need to determine its value today. In this video, we're going to assume that we're calculating the value an investment will grow to over some period of time. Our equation for future value is that FV, or future value, is going to be equal to our PV, or present value, times the quantity of 1 plus r to the t, where r is our periodic interest rate and t is going to be our number of time periods. The quantity of 1 plus r to the t is known as our future value interest factor, which has the acronym FVIF, and we'll see later in the video how we might use that to calculate a future value. For future value, we will likely use a couple of different functions on your calculator, including a yx or x to the y button, or maybe the caret key to raise something to an exponent. In these calculations, it's important to note that our R is our interest rate per time period. And so, for example, we may have an interest rate of 12% per year. And if we earn interest on a monthly basis, then we would take our 12% and divide it by 12. In other words, 1% per month. Our T is going to be the number of time periods. And so if we earn interest on a monthly basis for 10 years, then we would assume that we would earn interest over 120 time periods, which is 12 times 10. In some cases, one variable might be given as periodic, for example, 120 months, and the other in terms of years, or an interest rate per year. In this case, we'll need to make sure that both variables are periodic. In these first simple examples, we will use an interest rate per year and a number of years that we save. Time is going to be the number of years multiplied by the number of time periods in a year. Our formula is usually going to use T. It might use T times M or N. Our calculator, it's normally denoted with an N. Our interest rate is going to be our periodic interest rate. In other words, it will be our interest rate per year divided by the number of time periods per year. It could be denoted with an R, or R divided by M or I on our calculator. It's usually denoted by an I over Y. Our present value is going to be the cash flow at time 0. It's going to be the amount that we save today. In certain types of problems, we would call it a price, usually denoted by a PV. Our payment is not applicable in this example, and our future value is going to be the amount of the cash flow in the future. It's going to be how much our investment is worth at some point in the future. So the first example, suppose you have $100 today. Your bank pays 2% per year, which we would call an annual percentage rate, or APR, on your savings. What is the value of your $100 investment in 5 years? And so if we look at a timeline, we see that across the top we have our number of years. And in this case, again, our T is going to be adjusted for the number of compounding periods in a year. Because we're talking about a number of years, there is only 1 year in a year. And so our T is going to be equal to 5 times 1, or 5. Our interest rate is going to be our 2% divided by 1. And our present value is going to be $100, and we're going to compound that, or use compound interest to find the future value after 5 years. We'll also see that our future value equation there on the bottom, future value is equal to present value times the quantity of 1 plus r to the t. And so we have our inputs, and our future value is going to be equal to $100 times the quantity of 1 plus 0.02 raised to the 5th power. In other words, 100 times 1.104081, which is going to give us a future value of $110 and about 41 cents. If we want to use our financial calculator to calculate the future value in this example, we would first find our future value interest factor and then multiply it by our present value. In order to do that, we would take 1 plus 0.02 equals, then use our exponent button, or y to the x button, and raise it to the 5th power, equals, and then multiply that by our present value of $100. And we find that we get a future value of $110 and about 41 cents. The second way would be to use our parentheses on our financial calculator. So if we clear this value, we could take our present value of $100 and multiply it by a quantity using our open parenthesis. And now we want to make sure that we include everything that we're going to multiply our present value by. So in this case, I would multiply it by 1.02 raised to the 5th power. And then I'd select the close parenthesis. And we find that that's the value of our future value interest factor. And at this point, it still has 100 times this quantity stored. And so if we hit equals, we will see that we get the same future value of $110.408. And so with this example, we could use our future value interest factor table, where our future value interest factor FVIF is 1 plus r to the t. And what we would do is simply find our interest rate. In this case, it's going to be an interest rate per time period, but we're dealing with years, so we can think of it as our APR, or annual percentage rate. We have a value of 2%. And our time periods, in this case, we're dealing with 5 years. So it'll be 5 time periods. And we find the intersection of the column and the row of 2% and 5 years. And we find that our future value interest factor is 1.10408. And so when using that future value interest factor, we could take our present value of $100 and multiply it by 1.10408 to find the value that we had before of $110 and about 41 cents. In our second example, suppose you have $500 today and a CD promises to pay you 5% per year, where a CD is simply a certificate of deposit from a bank where they pay interest on your savings. Normally it has to be saved in the bank for some amount of time, a month, 3 months, a year, 3 years. And you want to know what is the value of your $500 investment in 3 years. And our timeline will look like this, where we have 3 years across the top. Our t is going to be equal to 3 times 1. We multiply it by 1 because there's 1 year in a year. Our interest rate is 5% divided by 1, or 5%. And our present value is going to be $500. And we're going to find that future value after 3 years. So here we see our inputs, where our t is equal to 3, our r is 0.05. Our present value is $500. And we find out that $500 times 1.157625 is equal to $578 and about 81 cents. And so there are a couple of different ways we can think about this on our calculator. One way would be to take our future value interest factor and calculate it first. And so we would hit 1 plus our interest rate of 5%, so 0.05 equals, and then we would use our exponent button, so we could raise this using our yx to the 3rd power, so 3, and equals, and that gives us our future value interest factor. And we multiply that by $500 times 500, and it equals, And we see that for an investment where we save $500, after 3 years with a 5% rate of return each year, we have $578.81. Another way to look at this problem on our calculator is to use our parentheses. And so we could take our $500 times the quantity, so we need to use our open parenthesis, of 1.05. Then we raise that to the third power, so we hit our YX button. 3. And we close that up, and the next value we'll see will be 1.05 raised to the third power. Right, so it finished that operation inside of the parentheses. And now we've already told it to take $500 times the value that's in parentheses, so all we need to do is hit equals. And we see we get that same $578.81. There are some relationships with future value, and for a given interest rate, the longer the time period, the higher the future value. So in other words, if we were to hold our interest rate constant, the longer the time period or the longer amount of time we have invested, we're going to be able to earn more interest and therefore have a higher future value. And if we hold our time periods constant, the higher the interest rate, the larger the future value. The effect of compounding is not great over short time periods, but it starts to add up as the time horizon grows. In other words, as we start to save more money, we'll see the benefit of compounding where we earn interest on our interest. And so here we have a picture. And we see different values. So for example, if we look at 5 years, and we have different interest rates of 0%, which is that bottom solid line, all the way up to 20%, which is the 2 dashes and a dot line at the top. And if we wanted to save $1 today, we'll see the future value on the left-hand or y-axis, and the number of years on the x-axis. And if we were going to save for 5 years and earned 20%, we could turn our $1 into $2.488 after 5 years. And after 7 years of growing our $1 at 20%, it would be worth $3.5318. And what we see is that if we have some time period, if we increase t, right, from 5 years to 7 years, then our future value is going to increase from 2.48 to 3.58. Again, where our future value at time 5 is going to be $1 times the quantity of 1 plus 0.20 raised to the 5th power of $2.488. And if we perform that same calculation at time 7, we find that it's going to be worth $3.583. And so what we see then is if we hold R constant, if we hold the interest rate constant at 20%, as we increase t, our future value is going to increase. And if we hold our time constant, right, if we only look at 10 years, if we hold time constant and we increase R, or our interest rate, we'll see that future value also increases.